Hello everybody, welcome to another video lesson. Today we're looking at verifying trigonometric identities. At the end of this video, we'll be able to verify trig identities by evaluating both sides of an equation or just one side. So let's take a look at our concepts. All right, verifying our identities. Really, our identities, they're going to look like equations that you'll be given, and we're either going to transform one side of the equation or we're going to transform both sides of the equation. By transform, I just mean manipulate using other trig IDs that we know. So we got two examples here. So on the left-hand side, we would go ahead and say, okay, 1 plus cosine theta, I'm not going to touch that. I'm just going to leave that as is, and I'm going to manipulate the left-hand side of that equation until it equals 1 plus cosine theta, until it equals this side of my identity, okay, or my equation. And then for this second example, and we will say we would do this method 1 if one side of the equation is pretty simple. If it's pretty basic, pretty simple, there's not much going on, then I'm going to leave that there as it is. There's not really a whole lot that I can do to simplify it anymore anyways, so I'm going to leave that as is. But if both sides of my equation are a little bit complicated and we can go ahead and simplify both sides, then we would simplify both sides. So I would simplify the left-hand side as much as possible, and I would simplify the right-hand side as much as possible. Okay, so that's it. Those are our two methods. That's what we're doing today. Let's get into our examples. Okay, first off, we're going to verify that cotangent squared x minus cosine squared x is equal to cotangent squared x times cosine squared x. All right, so let's go ahead and leave this left or the right-hand side as it is. I'm not going to do anything with that for now. So now I'm just going to look at this left-hand side and say, okay, what can I do here? Well, if you're ever in doubt, just go ahead and put everything in terms of sine and cosine. Everything in terms of sine and cosine is usually a good place to start. So I'm going to rewrite cotangent squared as cosine squared over sine squared x minus cosine squared x. We still have this guy's coming along for the ride. And I can then factor out a cosine squared x from both of these terms. So it's going to be cosine squared x is equal to 1 over sine squared x minus 1. Okay? Now, sine squared x, I know is a reciprocal function for cosecant. Okay, so that's going to be cosecant squared x minus 1 inside my parentheses. And we still have this times cosine squared x. Now again, I'm not doing anything on the right-hand side of my equation, just leaving that is. I'm just working with the left-hand side now. Now we have a Pythagorean identity that says that cosecant squared x minus 1 is going to be equal to cotangent squared. So if I simplify that then and substitute cotangent squared in for what we have in our parentheses, then I would get cosine squared x cotangent squared x is equal to cotangent squared x cosine squared x. And that is exactly what we have here on this right-hand side that we started with. So we have verified our identity. All right, let's look at another example. We're going to verify that tangent squared theta times cotangent squared minus cosine squared is equal to cosine squared. Now again, cosine squared is pretty simple, so we're going to leave that as it is. And again, I'm just going to go ahead and put everything in terms of sine and cosine on this left-hand side. So cotangent squared I'll write as cosine squared over, sine squared over cosine squared. Cotangent squared I'll write as cosine squared over sine squared. And then I'll leave this cosine squared here as it is. Now I'm going to distribute what we have outside of my parentheses into my parentheses. All right, and I'll be left with sine squared cosine squared over cosine squared sine squared minus sine squared cosine squared over cosine squared. Okay, so a lot going on here, but we can see that we can simplify this whole left-hand side to 1, right? Or this whole first term to 1. And we've got cosine squared over cosine squared on this second term. So those are going to cancel out. So I'm left with 1 minus sine squared theta. And we know we have the Pythagorean identity that says sine squared minus cosine squared is equal to 1. So if I were to solve that for cosine squared, I would get 1 minus sine squared, which is exactly what we have here. So I would say cosine squared is equal to, what we have here, awesome, cosine squared. Those two are equal to each other. We have a true statement, so this identity is verified. All right, third example here, verifying that cosine squared x secant x cosecant x is all equal to cotangent x. So to start us off here, I'm not going to touch this cotangent. I'm just going to leave that as is. And I'm going to, again, rewrite everything over here in terms of sine and cosine. It's a good starting spot. So then I've got cosine squared x. Now, I've got this times 1 over cosine squared x times 1 over sine squared x, because the secant and cosecant are the reciprocals for cosine and sine. Now, keep in mind, cosine squared x is another way of writing cosine x quantity squared. And cosine x quantity squared is the same thing as cosine x times cosine x, right? So I've got two cosine x's being multiplied together here. So I'm going to rewrite it like this, kind of just getting the long way to this simplification, but hopefully you can see now that these two cosine x's would cancel out, right? And I would still have one of my two cosine x's outside of these parentheses. Okay, so now I have cosine x over sine x, which is equal to, remember, cotangent x. And cotangent x equals this cotangent x that we have on the right-hand side of our equation, so that checks out. All right, last verification here. We've got cosecant squared minus cotangent squared is equal to cotangent times tangent theta. So now I'm going to work with both sides of my equation here. I'm going to work with both the left-hand side and the right-hand side. So first, let's take a look at this left-hand side. I'm going to rewrite everything in terms of sine and cosine. So cosecant squared is going to be 1 over sine squared minus cotangent squared. I'm going to rewrite as cosine squared over sine squared. Now that's going to be equal to what we have on the left-hand side, again written in terms of cosine and sine. So cotangent is cosine over sine, and tangent is sine over cosine. So can you see here that since this is multiplication, all these are going to cancel out, and this is just going to be 1 on the right-hand side. All right, now since I have I have a common denominator of sine squared on this left side, I'm going to put this under one fraction here, under one rational expression. So I just combine our numerators here to be 1 minus cosine squared theta over sine squared theta. And that's going to equal this same 1 that we have here. Again, we have the Pythagorean identity that says this numerator is going to be equal to sine squared theta. So sine squared theta over sine squared theta does in fact reduce to 1, and we're left with the expression 1 equals 1. So we have verified that identity. All right, guys, that is it for this video. This concept takes a little bit of creativity sometimes, but if you're ever stuck, remember, put things in terms of sine and cosine and see what you can do from there. Okay, that is it. Good luck with your practice.